I'm Vanessa. I'm ML engineer. My background is on computer science engineering and specialization in the cloud development and machine learning. I work at the European Central Bank building ML applications from ML fine-tuning to bringing those for production setups. And here bringing you today how we can bring solutions for production that go beyond just the normal chatbot, and also issues that I faced along the way that I can also share to maybe also help you out in that demand. And so I will start with talking about different ways of how we can orchestrate these solutions for these complex GenAI applications. How some of these GenAI applications can also leverage at some of the steps from fine-tune LLMs, or when, for instance, when we bring agentic workflows, going full close with closed source solutions, or trying to integrate with fine-tuned solutions for these highly specialized tasks, and comparing a bit the approaches in terms of costs, latency, flexibility, and among others, and also diving deep a bit into like a demo on how I also fine-tuned the LLM for multitasking. Also then how, if this LLM works, how we can bring it to a production setup, and also some next steps, because we are in or I'm in an enterprise where a lot of these tools can also be reused and shared across projects. So how like actually MPC servers could make sense for these. And just a bit of previous work that feel free to check it out, and then I'm like also available to discuss. So actually, my previous ML con iteration, I came here with a very specific problem. So instead of being like very complex tasks, it was actually a very specific task where I just knew that both my classification model and the GPT-4 had its limitations. And at the time, what I did was to fine-tune an LLM, smaller LLM using supervised fine-tuning techniques and also reinforcement learning techniques that then helped me surpassing then the results with GPT-4 at the time, so 1 year ago. Also using just limited resources. More on in this article, and I can also ask any questions that you might have after. But so let's dive into what brings me here. So there's different use cases, especially at the DCB, where we have highly specialized tasks and where more than a single LLM call is necessary. And as an example, a style guide module where you need to apply multiple ACB style guide rules, for instance, moving from US English to UK British English, also applying some number and currency-specific formatting, and so on, to even more complex use cases where you have council meeting transcripts to final meetings. And here, imagine you have different people with different opinions, and you need to have a final statement for what was the final decision. So it goes through different layers to first finding like the main categories or the main topics being discussed, seeing which people discussed about these topics, who agreed, who disagreed, what was the final decision. So it goes through a lot of steps to get to the final minutes. It's a very challenging use case, but also very interesting. Here today I'm going to focus on the style guide module, which I think also it will be easier to explain and to visualize. And in the end, also is something that we want to use across these different projects, even for this one, for these transcripts as a final step, because in the end it helps maintaining the tone across the different types of communications that we have there, and also reduce the time spending on editing and proofreading. And it's going to be basically what I'll bring you today. And starting from probably what you also already concluded from your experiments. If not, I can show you here some results. So here we have two charts. One, and both, you can see that in both we use an evaluator score. I will explain you later how I come up to this evaluator judge score. and what we are comparing is if we have, for very large documents and for very complex prompts, impact in performance and how like slightly adjusting the way we make these calls can already improve the outputs. So when you see like a single call for a document with more than 1,000 tokens, you would what would happen is that parts of the document are just forgotten or like give less importance to, and you see a score of 1 because of you were really missing important information that was not acceptable for the editors. And when you instead, if you split a document into multiple calls and analyze each part individually, then you can still keep that performance high. There was also impact on performance when the prompts were very complex. So I've also discussed with some of you like before, so I find that we've been in the same path, that if we actually split the big prompt into multiple smaller ones, more specialized, it also tends to yield better results than we just ask one prompt, because it stops or it doesn't apply everything. It doesn't give importance to everything that you put in the prompt the same weight. And so those are the first results. And with that, I moved to multi-prompt with a chain of thoughts approach, which is actually one of the ways I would say is a starting process to start orchestrating these pipelines to deliver these outputs. And when you come to production setup. And it's actually something that I will show you how our current pipeline that is in a production for a sample of users, how it looks like already. Yeah, we have different ways, or I have evolved in different to different pipelines, starting with the chain of thoughts, then moving to an agentic workflow that integrates some automation as well, and then also changing parts of this agentic workflow with some LLM fine-tuned calls that I will also explain a bit more in detail. But yeah, so this is here the chain of thoughts, the one that I said that is already in this controlled production environment, just to a limited set of users with which we are collecting feedback. And so here, what you can see, so you have different calls, also done sequentially. So the output from one is the input for the next call. And for instance, on the handling abbreviations and preferred terms, what we do is that we actually first have a rule base to detect if abbreviations or preferred terms that are ACB specific are mentioned there, and if so, then we send an LLM call to replace it properly, to keep with the verbs, with the tone and everything. So that's the first LLM call. Second one, to general English improvements, to do this change from US English to UK British English. Also then passing to stylistic improvements, which are specific ACB ways of writing for some communications. Then inclusive language, when you say something like he said, she said, according to they said, not for all types of communications, but in some this was required. Then for currencies and number-specific formatting, which also then needs to be applied when it matches the rule. And with that, in the end, we had a final style improver output, which we could evaluate using an agent evaluator that we'll explain a bit later how I get there. But yeah, so this is basically the setup that we have, stable, but still with some limitations. Like with this type of setup, what happens is that I always, because it's sequentially and I don't really select or detect which rules, I always go through all the steps in the pipeline, which means that even if not all the rules need to be applied, I still go through them, which then happens, and most likely also you face the issue, LLM tends to always apply the change, even if it's not, apply some change, even if nothing needs to be changed there. So this was a problem that, does not make it time efficient, because then we go through we apply extra calls that we don't need, and also you can change inputs that are not desirable. And so what if we could have something that detects these rules and then only selects the set of steps that we need to apply? So this was something that we also then integrated. And these Agentic critique just detect which rules need to be applied and then go sequentially through the steps that are through the rules that that were detected that need to be applied. In the end, we have also this output, and then we also can evaluate. It still has some limitations in the sense that our Agentic critique, because it's all, in the end, an LLM call, you're limited to what fits there in the context. Our Agentic critique had to be very conservative so that it could not miss important rules to be applied. And also, the Agentic steps did not handle that well edge cases. And so here also brings the point that if the rules are relatively stable, straightforward, and they are also highly frequent, and you really need to handle well edge cases, can we actually have LLMs that are fine-tuned for that very specific tasks and rules in this case to help suppressing this limitation, but also have a cost-efficient solution in the long run? And so, so that's what I wanted to test, and this is one of the things that I'm going to present some results on. And so here you have the same diagram. What happens is that behind each of these rules, you just have a call to the fine-tuned model that does the prediction. And I wanted to explain a bit also how I get to that fine-tuned model. Because in the end, you need to fine-tune it, you need data, and that is always the critical part. So I think sometimes we need to also think a bit outside the box. And we had two initial data sets. So the ACB style guide, so the PDF with all the rules and some examples that we had to follow, which we extracted to build the prompts. And second, some examples of draft reports with input and outputs. So text from editors of how the text started and the final version. And so I was like, OK, so what if we actually we send this to the LLM asking, OK, what are the steps, what are the rules needed to go from input to output? And with that, I got two things. First, the rules detected and written in a way that the LLM understands them, so that it's not the way that I would write and understand them, but in a way that the LLM would understand them. And the second, then we get a much more granular data set where we have, for that same input, a list of rules with input and output. So what was originally there and which part was the one that changed for that particular rule. So we got a much more granular data set, and then also written in a way that was more LLM language understanding, if that makes sense. And I used it both for the prompt tuning, so to improve the prompts that I already had there, and also then to create this data set that had the rules, the input, and output. So the part below then with the fine-tuning of the Agentic critique is something that we're going to do after. It's not yet, we haven't done yet, although I feel like it's a bit of what I also did last year. So it's an easier task, something that also because we know which classes we need to go, I find it's much easier to evaluate and to get something sharp. But the one that I'm presenting here results today is on the fine-tuning with this Agentic style improver for these different calls that we do here. And after the fine-tuning job was done, we had some examples that were used for UAT with ratings and comments from experts. So from some of these fine-tuning outputs, plus from the GPT-4o outputs, ratings from the users that helped understanding if your outputs are good or bad, but also that then I use to fine-tune, not to fine-tune, but to prompt engineer the agent evaluator that then serves as the evaluator for the different fine-tuning methods. And the nice thing of this evaluator is that, of course, it's not perfect, but it's something that I have to evaluate the different tasks and the different models that I'm fine-tuning. And also, the way that was tuned was to try to be more conservative or less conservative in line with how the experts would rate also the outputs. Because also with the comments you could see what would things that they penalize more and less. And so, yeah, so basically we had these three main agents, the agent critique, the agent that is the style guide that is expert in these rules, and then this evaluator. Yeah, also just to few points on the fine-tuned LLM methodology, and I'll show you after some important steps along the way of fine-tuning. But yeah, so high level, I did supervised fine-tuning with Keylora and with Laura. But so yeah, with Keylora, then you have the advantage that you can run the model in a smaller size. But in the end, also Laura helps. It has this expression that you learn less, but you also lose less. So especially for these smaller, simpler tasks, can be something that yields very good results. So I would totally recommend to start from there. And I'll also show you like when we do Laura, what parts of the model we are actually changing. I can spend more time on that or after. It depends on how much time we have in the end. Then the data set had input, expected output, and the rules to be detected. This data set I told you that I was preparing before. Then we have, I actually used a lot of Hugging Face packages. I will show also more on that. And hardware was an NVIDIA A100 GPU, 24 gigabytes of RAM. With that, let's dive into the comparison between the different solutions. And the different criteria to focus on are performance, of course, quality and latency-wise as well, cost implications, and the flexibility. When you need to bring these to a production setup, like what you need, does it really make sense always to maybe go with one solution or the other? So I'll go through that. And here you can see already like a comparison of the different models. So you see here, just to introduce the graph, so you have individually the rules and the results for each of the rules. And you also see different models here. So GPT-4o, which was the basic model we use for the agentic workflow. The different llama variations, so using a bigger one or a smaller one, because I wanted to understand if with smaller model we can really get to very we can actually deliver for these specialized tasks. And also a variant that I did in the beginning, which was using sequential tasks, so fine-tuning the model one task, then fine-tuning that same model with those adapters for the next task, and then for the next tasks, versus combining all in one data set and just training all together. And so with all these, I have three main conclusions that I want to share, starting maybe with this one with sequential or combined multitask training. So I actually saw that with sequential training, I had the impression that after each training iteration, it was starting to lose some of what I had learned and was doing right for the previous task that I was trained on. So I feel like it was not very stable, and was forgetting parts of the training. And you can see overall that is also the one that is performing worse. But right after you have then the llama 3.21 billion, which performs quietly okay. But yeah, so the first conclusion that I wanted to say was indeed like the sequential task training that I don't think is yields good results. Maybe you also have experience on that and we could also exchange. Happy to do that. My second conclusion is you can see that for the smaller and straightforward tasks like currency changes and abbreviation handling, preference terms handling, punctuation, inclusive language, those are very straightforward tasks. You have a set of rules that you know you need to apply, and it seems like even the smaller models are really able to deliver. And I find that I think that's very interesting. If you think that maybe if your task can be broken down into smaller tasks, that maybe you can actually deliver with a model that was just trained with that combined set of tasks and rules, and be able to reach performance at the level of bigger models that are just more expensive. And I will show you also with more latency and so on. And so this is also second conclusion. Third conclusion, looking at the first two, which are by far the most challenging tasks in the workflow, which is general English improvement. And this one you see GPT-4o far ahead, because indeed here you need a bit more reasoning capabilities. And I would say that if we I think we could still break down further that general English improvement and maybe then increase the bit performance for the smaller models. For instance, a colleague of mine actually did a test with the past shift tense. Past tense shift, that he did some, like he also did with a smaller model. He was not with Llama, he did with Queen and with Phi. And he actually managed with also a smaller data set to just solve the issue for that small rule under the general English improvement. So maybe what happens at this task is very complex and you need to break it down further. And then stylistic improvements, it's a very special case because I feel like this one is very subjective, and even what is right for some editors is not what other editors would do. So yeah, because this is more style, this is more subjectivity. So, and you can see even GPT-4 does not perform very well, and it's something that. Or you also manage to break it down to maybe smaller and very simple tasks that we know that we need to apply here, or I think we just drop it from the pipeline because in the end, doing something wrong or something that some editors agree, some others don't, yeah, in the end you need to have a pipeline that is stable or as stable as possible. So I would do one of these things, or break it down further for these more complex tasks, or maybe drop it from the pipeline. Or then use, as the case of general English improvements, something that is just for more complex reasoning, you still keep it there, and yeah, and you combine for different tasks the different models. And but let me show you some examples. And here, like I have two examples. One where these original and where what we need to apply is just the preferred terms. For instance, these biannual EBA stress test activities that needs to be or is expected to be biennial European Banking Authority stress tests. Or in the example 2, where you have punctuation to be applied and you have a number specific format to be applied. And overall, all the models handled well these cases. But an example that actually was far more complicated, which was like here you had 3 statements with multiple rules that needed to be applied. In the first statement, yellow, you see you have abbreviations, you have a style improvement. In the green, you have just general English to just change it to lowercase, and in the last one is just the punctuation to actually remove the Oxford comma. And so yeah, so this is also then you can compare it with the expected. And now like I'm just going to show you like just some examples on how these different models performed. In the end, like this is not like a perfect. These are not going to be a perfect example. Just also to give you an overview on how these different models like compare to each other. And for instance, here in the GPT-4o, we actually missed the task for the abbreviation. We actually didn't do it. So it's not that all these models always perform very well. Sometimes they still fail. That's why they're not like perfect scores. But actually something that GPT-4o did wrong here was for the mix with the style improvement rule and with the second statement, where because it changed the place of the second statement, he actually made this part that says as a Eurosystem SSM-wide about a different subject instead of being ACC to be conduct risk task force. And because it's changing these, it's also changing slightly the meaning of the sentence. So in these types of examples, it's very critical that you change as little as possible and to focus really on the task. And you have here examples that even GPT-4o like messes up. And these are the cases that then the editors like do not really tolerate because you really change the meaning and you cannot have that. Then here for other examples with Llama 3.1 8 billion and the 3.2 3 billion, where the 8 billion does not change the meaning, but occults parts of the original text, and the 3 billion model, the text abbreviations, but actually applies another one, so it just hallucinates there. So you still, yeah, the smaller models, I feel like they tend to fail more in these scenarios. And then the mixed approach, which actually uses for the general English rules, the GPT-4o, but for the other smaller ones, applies the Llama 3.18 billion. And also here I was not applying a sizing improvement, and you see that overall it's the most stable. But like in the end, like, it's not only like the quality that matters. There's all the other parts to bring to attention. And here you have two charts: one with the latency impact, and another one with costs estimations of each of these workflows. So in looking at the latency, like GPT-4o takes much more time than if you actually use a smaller model, especially if quantized. I actually didn't mention here, but the Llama 3.1 8 billion is not quantized, but I will explain a bit after why. And then the combined workflow with GPT-4o and with Llama. So you see here 7 calls. So it's actually 3 in total for the GPT-4o and 4 for the Llama, because it's the critique. So the first critique to detect the rule, the general English and the style improver, and the other one straightforward is with the Llama. And you see that it takes around half of the time that GPT-4o takes. And when looking at cost estimations, you see then the default cost for the model that you need to host, because it needs to be there. I'm not even including here like considerations about auto-scaling, that maybe we need more resources or less, would be something that we need to be compared also, and would probably increase also costs later. But just considering having a GPU there running with your model. So both Llama, so both the green and this combined workflow with need that. And then here you have the costs per 1K input token and cost per 1K output token, which are applied for the combine and for GPT-4o. And the combine you see a bit more because in that request you would have 3 calls. And then, yeah, when you wrap up into the total costs for the 7 calls, you see that also GPT-4o would tend to have double of the costs compared to using the combined workflow, or even like much more if you combine with the self-hosted solution. But in the end, like looking at these, seems obvious that you go maybe with the combined workflow. But in the end, that's not the only thing you need to look at. You need to have, especially when bringing something for production, you need to think of something that is stable, that you need to maintain it after. You need to also maybe be flexible to later handle other tasks as well, because otherwise you start having a lot of models and hosting a lot of models, and can also get very costly easily. So I think you need to really think about for different setups, like the answer might shift. So for instance, like if you're handling very complex and less predictable scenarios, most likely stick with something that is more flexible, like GPT-4o or Claude. If you have a long-term, if you're thinking about something long-term, cost-efficient, maybe it makes sense to leverage from models like Llama, or even smaller models that can be performant for if broken down into smaller tasks. But I would really avoid the self-hosting if unless the task volume is very high and the model really provides the flexibility for the task that is necessary and for other tasks that you are thinking of including in your company or in the projects that you're running. And so I would now walk you through a demo of the steps that I've been through for doing the fine tuning, and I can also share then some of these resources. So here, starting with the setup, so I will in this notebook, I've actually done the fine tuning for both the larger model and the smaller Llama versions, and you can see, for instance, here we're running an NVIDIA A100 with 24 gigabytes of RAM. For instance, the model, the 8 billion would need 15 gigabytes of VRAM. For the training, if you quantize the model, it can actually go down to 4 gigabytes, which make it much more feasible for training. Then you also need to accommodate a bit for the training parameters with the LoRa adapters, but you can have an idea, more or less the size you need. With these, and then also looking at the libraries, you see a lot of Hugging Face libraries that were used. I always like to put the versions because you can have also very incompatible versions a lot of times and get errors that you don't really understand, and then it's because of the versions are not compatible and stuff like that. So yeah, so maybe they can be helpful. And Yeah, so then I want to focus also on showing a bit how the data set looks like. So here, for instance, for one of the tasks, a task that was number specific, you had here the prompt that the task was supposed to improve the input that I'm sending, following the number specific rules that are here. And then I specify here all the rules, so write the numbers up to and including 10 as words, numbers from 11 onwards as figures, and so on and so forth. And here you have the input, and here you have the completion that you expect. And you load the dataset like this. And here I will also have examples, but they're actually like generated with the GPT, because as you can see, it's very general, like examples, just for the purpose of the demo as well. And then, like, yeah, so this is just normal definitions. Here, the tokenizer, very important to look if your tokenizer has a chat template. Usually, if you're using an instruct-based model, you already have a template, but it might be the case that it doesn't have, and then you need to add so that you really clearly tell the LLM where to start, where your input start, and where your instructions start, and where it ends, and where should the output, and how should output look like. So it's important that you really have the tokenizer, the template set properly. For instance, actually, the model max length is something that I had to set up after because I was having issues when deploying it with the VLLM. But yeah, just something to consider that just also limit the model max length. Also, quantization, if you need to quantize the model. And here, the LoRa adapters. And I want to show you here that you have the rank, the LoRa rank, the LoRa alpha, and a dropout. And you see here that our target models are linear. Yeah, I wanted to show you here that, like, so this is, for instance, how the architecture of the model, so how it looks like. And what we do when we say this with LoRa is that we are going to, exactly in these linear layers, to add two new adapters, A adapter and a B adapter. And when you have here the LoRa, and I think I set it for 32, then it means that, for instance, here you have the out features 2048. So that will be the input features for the adapter A, and the adapter A then converts to 32, and 32 is going to be the input for the layer B, that then is outputs back to the 2048. And with that, you just have much more parameters, which then will be your trainable parameters that you're going to, in the end, to fine-tune. Yeah, so I want to touch on that. And then a quick mention also on the tokenizer. So in the end, if the tokenizer is not there, you need to create a template yourself with an instruction, the input, the response. If it's there, then even better, and you just apply that chat template to your examples. But it's important that then it looks something like this. So it's going to have, this is basically the parts from the tokenizer that are applied, and it needs to finish this to know where does the output then start, and then here you know that then it's finished. This is very important to avoid any hallucinations. If you have hallucinations, most likely start checking these, because it might be here the problem. Yeah, and so here maybe you also see another example. Maybe interesting to see these little changes and rules that we apply. Yeah, and then for the you just define the configurations for your supervised fine-tuning. If you want to apply other techniques, for instance, earlier I mentioned the ORPO, DPO, so these pre-inference optimizations techniques also there are also functions for these or classes for these that you can see in the provided already from Hugging Face that will make your life much easier to do the training work. Yeah, and to mention here, learning rate is something very important to change. Start maybe with the one that I have in the paper, and then go changing and adjusting, depending also on how much data you have. Yeah, also batch sizes, very important to tune. and so on. And I think the best way then to check like how much is learning or not is to go to like report to TensorBoard, and then you can load one small server with the TensorBoard and see some results. Also, I realized after that actually when you push the model to the hub, you can also have a section which includes the results from your training and your evaluation, which can be very, very interesting. In the end, I feel like for general supervised fine-tuning, you can also have these results basically from when you see the training loss, when you analyze the training metrics, evaluation metrics here. But especially for the other reinforcement learning techniques that I was mentioning earlier, the TensorBoard really has a lot of other metrics that are also collected during the training, which can also be very useful. Yeah, in the end, you finish the training, and what happens when it finished is that you saved the adapters. You didn't save the new model with all with this training information. No, you saved only the adapters. And imagine that now you actually want to use. You think like, okay, now my model is ready to push for the use with the VLLM serving host engine. Well, not really. You really need to have a model with these adapters included, so a merged version that then you use for to be hosted. So all this consider that. So yeah, so you need to to merge that. And I also show here like how you do that. So you basically just load again the model, and then you just do the merge and unload, and you save. You can also then include there the tokenizer, but the tokenizer is not going to be changed. You don't need to merge anything. The tokenizer is going to be the same as it was before, and then you just push to hub if you want. Yeah, and in the end, just for instance, an example when you can see, and here, of course, I think that's what matters, where you compare the outputs from the before training and after training to see if indeed it learned and improved. And yeah, here you have here, so I loaded it with pipeline, and then you see an example. So you had the task, you had generated answer, and you had then the expected answer. And of course, you don't stop here. Like you do some more iterations, you see in some more edge cases, you feel that your model is ready. Okay, it's ready then. Let's go to the next phase, which is deployment with VLLM. And here, when selecting what is the best inference engine for hosting these, and I hope the size was fine, but I can increase, by the way, if you need. But yeah, when selecting this engine, that's different things to think of, like the throughput, the latency, the API compatibility. I liked very much the latency for VLLM, and I tried with TGI, but I didn't see really any benefit from that. Don't know if you also have experience. I'd be happy to exchange. But in the end, decided to go with VLLM. It can also handle better multiple concurrency requests, efficiency, and So I found that in the end, I was the most stable and easy to bring for hosting the model. But I really want to show you how that looks like. So for instance, you just you run something like this, so you define which model you want to run. You can have it locally, you can have it in the hub, or wherever is the place that you added, you put the model. So you just have the path for that, and then you just include where do you host, the D type, and the max model length. There's more configurations that I don't remember now, but you can set more things. Not the temperature for sure. For instance, temperature and other specific things for your requests go in the client side. And then you can see here that when I just try to make the model run, it needs to install all the tensors. So it really needs to install all the model. And I don't know if I have here exactly the push for the configs from the model. No, I don't think so. I cannot see it here. But basically, you need to have all the configs on how the model is defined, and these you only have after you merge. And so then it downloads everything, and then it starts having everything to start your application. And then I'm going to show you how you actually interact with these. So here in this example. So I had here an example on the how the instruction needs to look like for in the case for the number and for the currency. And you see already these. Also very important that you keep the template there to avoid, again, hallucination. And so I had here like the template. I had the example that was expected, the input, and the output that was expected. And I did that for us like a set of cases, and then also the suffix that I put after the input to know that it finished the input, so ready to get your model output. And then here in the request is where you set the max tokens, the temperature, and so on. And then you get your results. And I just run them before to avoid having issues during demos. Been there, done that. Don't want to avoid that again. So here different test cases where you have like your input, the generated output, and in the end what was expected. I think there's also an example here that nothing needed to be changed, but also it didn't change the text. But I think overall, so you can have different, just showing that it's really easy to then, like after having your model served, of course, in your company setup with your security and everything, your networking configurations, of course, then you'll just make the connection to your client that then interacts with it. And yeah, I think back to the slides, just on the just notes on these on when we deploy to production. So yeah, like I mentioned already, these different engine selectors that we can have. So TGI from Hugging Face, VLLM, Triton I only used for smaller models, especially when I needed to manage properly the context, so the memory used from the GPU and so on. But for these LLMs I haven't used yet, so don't know if they perform as well. As serving strategies, then is also the thing of thinking, okay, do you want to have just single model, multi-model endpoints? Auto-scaling should be something to consider. And model quantization, that in the end is something really important to take into consideration. In my case, I was having issues with the quantized version model, the 4-bit, so I actually had to just use a normal LoRa model. Infrastructure choices, especially in AWS, I use the inference family, so G5. You can also use GPU-backed instances and EKS, where you can also share the resources. I think that helps also to share a bit the resources that are being used. And yeah, spot versus on-demand cost considerations. Observability, this is one of the most important to also look at, to look at latency, token usage, best batch efficiency, check for timeouts for failures and so on. And then security, of course, especially if you're running your self-hosted models, and anonymization and logging might be something that is less of a problem. But yeah, it's important to, in the end, this point on responsible AI usage, especially if you decide to go with smaller models, and also account for the fact that these models do not have the same guardrails that other larger models might have. So yeah, like it's a trade-off. So in the end, maybe you need to put something extra if you're exposing your endpoint to the client directly. If not, if it's just your agentic workflow, maybe then it's fine. But if you need to have these if you interact directly with the customer, then it's something that you need to put on top. And yeah, so this I was already showing you in a bit. So I want to go and talk about just some next steps to wrap up, because we are in the hour, where like for instance now at ECB, a lot of projects actually might use the same chat interactions with the same databases, and MCP here comes to a play as a way of standardizing the way that we write those tools, exposing them in a way that can be discovered and accessible by other teams that also need to use the same resources, the same features. And yeah, I think for enterprise scaling, I think it's something that makes sense. There's different protocols that will come along the way, but I think that these main things like scalability, standardization, and also allowing for some other tools to also leverage from LLM, smart adjustment of the intents, and leveraging from different tools and combining the outputs that come from different tools. I find that there can be some potential with that. In the end, there are going to be a lot of protocols along the way, but as a starting point and to test, I think it's something worth it to look at. And for instance, a tool like the one that I just showed would look like this. So we'd have like our tool defined, where we describe all the tasks that we include there. That is, in the end, was running backed by VLLM, and then we integrate with in the MCP, and then it's like ready for interactions as just another tool. And in the end, I think that's it from my side. Hope that they also give some lights. And happy to hear your questions. Thank you.